So this talk's going to be about if you have an interest in monitoring what's going on in Postgres using uh, open standard, vendor agnostic, not getting vendor lock-in on monitoring tools. I'm going to just barely touch on actually what you can monitor in Postgres. So it's going to be mostly talking about the concepts and the terms and how to get started with OpenTelemetry, not too deep on the Postgres side. So let's get going. So what happened is back in earlier this year, I attended Linux Fest Northwest and found a whole day of talks on OpenTelemetry, like one session after another, different people, different organizations. And I was kind of new to it, and I was like, obviously this is catching on. So I got curious and decided to do this talk as a way of learning about this. So I am brand new. Take everything I have to say with a grain of salt. I'm not an expert on this. But what I did do is kind of document my progress learning. And so what I've got here is basically every little speed bump or problem I had or concepts I had learned to get ramped up. So hopefully save you a lot of time if you're new to this. So Postgres is a black box, as we know. It doesn't tell you what it's doing, right? You have to reach into it, start doing queries. And so our goal is to turn the black box into a glass box. That's my high-tech slide trick right there. So what we want to do in order to do that is to look inside, and the concept in the business is called observability, meaning we want to look at what's going on with the current execution and what the current state of any kind of a application or a service that you're running. And in our case, it's going to be the Postgres server itself. So the term telemetry is about the data that we're going to try to extract out of 4D, out of Postgres. And telemetry, the tele means remote, far away. The metry means measurements. And so it's all about getting the measurements, getting them out somewhere else. And in Postgres, we had, there are ways to do this. You can look at your logs, you can query system tables, there's plugins, and there's a bunch of tools. But the problem with these is that you kind of jerry rig them. They're all kind of separate, and they're Postgres only, and you need to find a way to make them work. So what has changed, that used to be good enough, but what's changed now is with the distributed systems. We've got real machines, we've got virtual machines, we've got Linux containers, we've got cloud servers. And so for people that need to monitor not just the database, but a bunch of systems related to it, that's what has made OpenTelemetry so popular. So what you're tracking with OpenTelemetry is signals, and they often call this the 3 pillars of observability: metrics, logs, and traces. So you're going to hear me say that over and over today. So let's look at each one briefly. A metric is a number, and it's measurement that you're making over time, intervals of time. And what's nice about those is that now that storage is so cheap and we have like time series databases and stuff that are optimized, you can store a whole ton of these things and to look at history and do analysis over time. And logs, of course, you know what they are, but it's good to get conscious of it, that it's a timestamp and some kind of a payload. And the payloads can be plain text, just description, but they can also be structured. And in some cases, they're binary, so not human readable, but meant to be defined by some protocol to be parsed later. And the third part is traces, which are a collection of spans where you are following a path of a request that is going across different kind of systems or services. And the span is basically, well, where you're going to do this is basically when you're calling out, changing threads or calling other systems. So a trace is a collection of the spans. Got my little key ring idea up there. Every span is basically a fancy log entry. So you're going to have your timestamps, and you're going to have an ID for that particular span, that one measurement. But the 2 key things is we're going to have a collation so we can get a bunch of these together and know that they go together. And we're going to also have causality. You can have a parent ID so you know which one led to the next one. And here's kind of the concept in play is that if you've got a request going through a bunch of related systems, let's say B there is, let's say the main request makes a call to B as a web service, and that web service calls out to the database. So that R is the database operation. Meanwhile, it could call some other kind of a library that also makes a database down in D, and that could be another database call. So all of these things you may want to track and put them together as a bunch of spans into one trace. So that's another key part of what's in observability. So the question is, how do you track all of that different kinds of data together? Get it together, transmit it, store it, and then provide it for analysis. Well, OpenTelemetry is the key to gathering it up and getting it into storage. So I'll show you a little bit more later. It's just one phase of that whole process. And OpenTelemetry came from two other projects. They were both open source, headed in this idea of trying to standardize in a vendor agnostic way. How can we collect all of this telemetry data from a whole bunch of systems? So what happened is these projects have actually been archived in the last couple of years. Once OpenTelemetry was up and going, they merged their efforts together. And that OpenTelemetry is owned by the Cloud Native Foundation, which is part of the Linux Foundation. This is not Linux focused, however. You can do this across all kinds of platforms. I'll talk more about that. So what exactly is the OpenTelemetry? Well, it's not one thing. It's a whole bunch of stuff. There is a specification and there is a protocol. And there's also semantics, which is kind of interesting. When I was listening to those other talks, it was funny how often they said just getting the terms straight. Every vendor, every kind of project had their own terminology and their own meanings behind it. So one of the great things about OpenTelemetry is that now these terms have been defined formally. And it also, along with OpenTelemetry, comes a bunch of tools. There are neat software development kits. If you were writing your own app or service, you can now provide your hooks for OpenTelemetry to get data out of your app by using software development kits they have written for at least 11 languages. And also there's registries, so that if you want to see what products are compatible with OpenTelemetry, there's at least 40 of them. They keep registries. Super handy. And and these tools, the products that work with OpenTelemetry are both open source and both proprietary. Some are free of cost, some are commercial. Oh, and what's cool about this is that the momentum for this industry, it's one of these rare moments where a bunch of industry players have gotten together and realized cooperating, getting this all standardized into one spec and one protocol is to everybody's benefit. In fact, some of those speakers I saw they kind of realized it was like a once in a career moment where you have this huge amount of sanity where everybody is focused on getting all the wagons hitched into the same direction. So the process, as I said, is we're going to try to get data out of our service or our apps, or in this case, Postgres. We want to collect that together. We need to store all that telemetry data that we're collecting over time. That's what they call an observability backend. And then later you're going to look at it, you're going to do queries on it and do visualization for it. So what we're going to focus on is Postgres on the server side, the target of what we're trying to monitor. And then we're not going to look at the right side, because that is the actual storage and then the visualization query tools for analysis. There are zillions of them. There's at least 40 that are already compatible with OpenTelemetry. And the whole point of OpenTelemetry is that you can choose, mix and match any of those tools you want, and you can switch between them if you want to. You are not locked in. Because the lock-in side is on this side. You have to have hooks into your, in this case, Postgres server or your app or your service. And so if you have deployed that across a whole bunch of servers and products, you do not want to be having to rip that out when you go from, say, a Datadog kit to a Splunk kit. So that's why the vendors have realized they can actually turn that work on this side over to OpenTelemetry compatible products. And if we zoom in on this, what we're doing, the key to how this works in OpenTelemetry is that there is a collector, which is a piece of software, and the OpenTelemetry project provides that. And it works. The collector is kind of a bad name. It's more of a proxy. It's a middleman. So between, in this case, our Postgres and our eventual wherever we're going to choose to store our data, we need to collect it. That's what the receiver does, is to get the stuff out of your targeted system. And then there is an exporter. So these are two more pieces of software. Really what the collector is doing is just sort of orchestrating these guys to work together. So you can have a whole bunch of receivers, you can have a whole bunch of exporters, and the data that you're getting with the receiver can be either the push or pull. So you can the receiver could either reach out to the target, which is what we're doing in the case of Postgres. It's going to reach out and make queries into Postgres to see what's going on. Or like I said, if you write hooks into your own apps or services, those could choose that, say, when certain events happen, that software could reach out and tell the receiver that some event just happened. So it works either direction you want to. And there's a third part, which is the processor. This is optional. When you collect your telemetry data, you may want to modify it. And there's you can have basically think of it as another plugin, another chunk of software can be invoked by the collector after the data comes into the receiver, it goes through the processor, and then it gets shipped out through an exporter to some destination. So this can be surprisingly powerful. I've seen examples of filtering it, modifying the data, deduping it. So if you have duplicates, you can choose to collapse those. And also interesting is redaction. So you can eliminate personal identifying information, or let's say one of your destinations coming out of the exporter is like an external consultant. There's certain things they don't need to see. Again, that could be filtered out by the processor. And it also does batching for efficiency. And there's three other parts. Two of them are not relevant. If you're starting out with OpenTelemetry, you can ignore these, but one of them is baggage. That's why I have strike through. The baggage is a key value store for extra data that you might want to have right along with the telemetry data. And this is actually not defined in OpenTelemetry. I was curious to find that it's the W3C from the web standards world. They define baggage, and they are just supporting it in OpenTelemetry. There's also the idea of connectors, which you don't need as a beginner, but the idea is that you could use a piece of software that implements both the receiver and the exporter APIs, and that just lets you feed this is called a pipeline. One pipeline could be connected to another pipeline. And again, not an issue for a beginner. But the other thing you do need as a beginner is extensions. I'll show a couple examples where you can, the processor up above is modifying the content of the telemetry data. What the extension does is modify the behavior of the collector itself. So I think I've seen references to like authentication. You may want encryption and authentication type issues. And I'll show you a couple other examples. And OpenTelemetry is written in Go, which, as I said, it's available on a lot of platforms. And one reason is because Go is very, very portable. So it's on Mac OS and Linux and BSD and Windows and a bunch of other platforms. And what the OpenTelemetry project provides is a full collector implementation. And they actually have 5 versions of it, they call them distros. And there's 2 of them that we care about. I'm going to show those next. Oh, there's also some third-party ones. They are still the same collector implementation, but they can be pre-configured for a particular product. So that's just for convenience. So the 2 that you care about as a beginner is there's a core distribution, which is just the collector itself and a few of these receivers and exporters and processors that come out of what they call contrib. So the contrib is a whole collection of repositories for these different software pieces. And this is handy to start with if you want to, because it's very simple, but it has very few of these little pieces with it. And they have now frozen that. They're not going to add any more to it. Some people like using this for absolute minimal production. You could deploy in production and then just add the particular pieces more that you need. But more handy for starting out, for experimenting and learning, they have this contrib version of the distro. And this comes with a whole bunch of components, including what we need for Postgres. So this little arrow is to remind you to grab that one. And they have some other ones. There's one that's OTLP is the protocol I mentioned. They did define a protocol, and the OTL is short for OTel, which is short for OpenTelemetry. The collector, though, however, also supports some other protocols because that are older, that predate OpenTelemetry. And so they're so popular that to make it easy for deployment, the collector already just supports those other protocols as well. But if you don't need those other protocols, the other older ones, then they have a distro that focuses just on the pure OTLP protocol itself. The eBPF is something I don't even know about. Linux has, apparently it's something in the Linux kernel for monitoring within the Linux kernel. And of course, there's Kubernetes, very popular now. So these are the same collector, but just different configurations. I was using Mac. They have nice instructions on the OpenTelemetry site. The documentation is pretty good, and apparently a lot of work in making them even better. So it explained how to just download one of these. The only catch is I found a little confusing whether it had that word contrib or not. So you, like I said, you want the one with the contrib, not without the contrib in the name of it for the collector, just so you have your Postgres part. And oh, by the way, I started using AIs, the artificial intelligence chat sessions, to learn a lot of this stuff. Amazingly useful. I was kind of surprised. And I started using it even to like find some of these URLs and product download pages. So what you do, where you spend your time in with OpenTelemetry is these YAML files for configuration. This is really, you're driving all the software, the whole collector. The collector is going to drive the different pieces, the receiver, the processor, and the exporters. You're going to tell it what to do just by writing these YAML files. So let's take a look at that. This one has three parts to it. If you notice with YAML, it's indentation matters. So if you notice at the top, we have receivers with some subordinate parts, and then we have exporters and we have service. So you can tell at a glance, we have three parts here. And we're going to see this over and over again. Up here is we are defining what receiver it is that we want to use. Then down here, we're telling it what exporter we want to use. And finally, the service is what actually makes it go. This is the execution. These are just defining what resources you want to use. This is actually defining the pipeline. Tells it, if you notice, we have names here of host metrics and debug. These are the names we've used here. We have an exporter named debug, and we have a receiver named host metrics. Host metrics is one of the built-in receivers that monitors the host operating system. So what I did to get started is to just look at the OS, some basics stats about how the OS is working, and then I added on the Postgres later. This I found is the new way for just dumping to the console. Again, handy if you're just learning. So instead of sending it off to a storage site, I'm just dumping it right on the console and looking at it. And let's see. So what you get when you download that collector is just, this is an ls on this directory, is I create the YAML file, and they give you the OTel COLs is short for the OpenTelemetry collector, and they have a README file. So that's all, it's one executable. Or if you download the other one, it's going to be OTel COL-contrib. And again, that's the executable that you're going to run. So it's super simple. There's only one piece of software that you're actually executing. And and then you're going to pass it, when you call it, you're going to pass it your config file. And to get out of it, there's no graceful way. You just do Control-C as far as I know. So this is an example when I ran it, and what I got was a whole bunch of stuff. And I've just shortened it to show you that what you're looking for is everything is ready, like I said, out of a whole paragraph. And then here's the example of what I was actually the useful part. And if we look at this, Yeah, if we look at this YAML file, you'll notice that up above there's this item with the colon and nothing below it. When you do that, that means you're going to get the defaults for that feature. When you have the colon and nothing after it, that kind of threw me at first. So you're just going to get defaults. And now, for example, I was getting several different things about memory. Just for practice, what I did is to say, you know what, I just want to see how much memory is physically installed on this machine. Well, it turned out if you look into the documentation for this particular collector, the host metrics, that these two were getting turned on by default and give me those three memory about free, how much memory is being used, how much is free and available. And I could add this by saying I want to see this feature is for how much physical memory is installed. So I turned off these with the false and I turned on true. And that's really your, like I said, this is your life of OpenTelemetry, is looking through the documentation, figuring out what features you want to turn on and off. So when I did that, now I get a different number. And this was a 16, it's right on my MacBook. So 16 gig machine is that number of bytes. And if you notice, then the output was not including the other numbers I gave earlier. So of course, you don't want to just dump to the console all the time. You eventually, in the real world, you're going to want to put it into some sort of the observability backend so that you can access that data later. And what I did, there are lots of products to choose. I arbitrarily chose the Signos, which is open source, and they sell a cloud service. They also sell commercial support if you want to self-host it, or you can just run it self-hosted without support, free of cost. It's your choice. And so I kind of chose it arbitrarily, but this did work really well for me for learning. So they had really good docs, and the scripts, the YAML config files I'm going to show you are basically cut and paste off their website. So I actually do recommend it for beginners. They have a 30-day free trial on the cloud service. So at least this part I didn't have to set up on my Mac. So this is the bigger config file that I pulled from them just for doing the host metrics, the OS stuff, not the Postgres stuff. So what we got, you can see here in the purple that these are the kind of features that we're going to ask it to track: CPU, disk, load, file system, network usage, blah, blah, blah. This is, remember I said there are other protocols besides the OpenTelemetry. Prometheus is one of those older protocols. It's a very popular product that does the collection. It used to do the collection, and I said people are transitioning to OpenTelemetry instead, but it also does backend and some analysis. So Prometheus is still a protocol that this tool is apparently using as its protocol to get data out. So we actually have two receivers going on here at the same time. And over in the other block, we have one called processors. And as I said, that's an example of a processor that's now batching for efficiency. It's putting a bunch of telemetry data together. The extensions I mentioned is modifying the behavior of the collector itself. In this case, you can actually do monitoring of the collector, which is doing the monitoring. So for example, you may want to make sure your collector is even up and running, and they have a health check extension for that. And it actually uses just HTTP response codes, so for indicating that it's either running or it's sick. And ZPages is another reporting it's a tool for getting information out of the collector as it's running. So, and those are optional but useful. And the exporters, we're going to use that OTLP protocol. And you notice the red text is part of the address for their cloud service. So like I said, they give a 30-day free cloud service. So I use that. And you have to point, the collector's running on my Mac. So the collector needs to know where to send this data out to this company, Signos. So that's the address. You have to change a region, which I found out is US, lowercase, if you're in the United States. And then the other thing you need to do is you create a key, which is permission, to identify me and my account. So all you do is you go into their website, you hit a button, and it will generate the key, and you paste it in here. And the service, remember on the right, that last column, that all of this is one YAML config file. I just broke it up so that you could more easily read it. The right side, the service is the last part. That's what makes it go. So now we are referring to these that we defined on the left. They're being named on the right. And we are handling logs and traces and metrics all in this. Again, I just copy pasted this right off their website, deleted comments to make it briefer. And I was very impressed that it worked. So this is an example where they are doing, the Signos company is doing the storage of the telemetry data, but they're also doing the front end graphing and queries. So this is actually, I know you can't read it, but well, I know you can't read it, but it's the CPU usage and memory usage right there. And in particular, I kind of laughed when I realized this little yellow line is my memory free. So my 16 gig Mac lacks memory. It's always maxed out. So I also, though, got an error with this. So you saw we had a bunch of different things that we were trying to query about the OS. I actually pasted this error message I got on the command line into an AI, and it said, oh, this is trying to access some particular things that are locked down in macOS for security by default. So I did not investigate further because the AI actually pointed out it doesn't mean that your other ones are not working. So one of them was failing, but the other, they also call these scrapers. So the parts that are being fed into the receiver, some of those scrapers are working just fine, like my CPU usage, my memory usage. So I do have some tips, particular Signos, which is I found one key point. I couldn't press a button it just didn't work in their website. And it finally dawned on me to check content blockers in my Safari browser. And sure enough, that's what fixed it. It was like just nothing happening. And all I had to do was to turn that off. I don't think this mattered, but I did the same, also allowed pop-ups. Also, they specifically said to use an older version of the OTel collector. And sure enough, I had gotten the latest. It turned out it did not work. And so I had to fall back to the number that they specified, and then it started working. And also their instructions mentioned wget instead of curl, and which there is no wget on a Mac. So they just made a boo-boo in their docs. And as I said, you can ignore, if you're doing a Mac, at least you're going to get that one error that you can ignore, at least when you're starting out. For production, I would want to investigate it. So now onto the Postgres side. And we have if we want to monitor Postgres, then we need to plug in a receiver that is specific to knows how to talk to Postgres. And then the rest of that on the right side is going to depend on the other tools that you choose. And where do you get the receiver? It turns out it's actually built into that OTel-contrib version distro that they have. It's already built in. You get it with it. You can also get it separate if you wanted to add it to a different collector configuration or distro. All you do is go to OpenTelemetry and hit ecosystem, and you're going to see just dozens and maybe hundreds of these different exporters, receivers. And from there, you will go to GitHub for the Postgres one. It's mostly managed on the GitHub site. And in the GitHub site, if you hit the, this is on the OTel contrib. If you want to see what are all those, what receivers, exporters, and processors are bundled, they actually have it as a file in the project. So you go to the manifest.yaml, and that is literally all of the parts. So again, I just did a search for Postgres, and sure enough, there it is. So I know that it was part of that OTel contrib distribution. And also, if you want to study what exactly does that Postgres receiver do, again, you go to the Postgres receiver's GitHub site, and there's a metadata.yaml file, and it goes on and on and on. There are dozens and dozens of things that you can access out of Postgres. So you would go through this file and start learning them. What are all the different pieces that you can get out? I just went with the default. I'll show you in a moment for the default of what Signos suggested. Now, because we're dealing with Postgres, your receiver's got to reach into Postgres and it's going to have to get make queries into it. So you need to create a user named whatever you want and give it a password. And then you're going to grant PG monitor. Turns out back in Postgres 10, to make monitoring easier, they added a predefined user role, which gives read-only permission to a lot of stuff that used to otherwise have to be super user. So, it's also going to be looking at the pgstat database for information. So you just run those on your Postgres side, and I just mentioned that, those two pieces. And then you're going to set some environment variables, or you can write these into the configuration YAML I'm about to show you. But this was kind of nice because there's actually we actually use these in for the Signos examples. They actually use them in multiple places. So it kind of made sense to have environment variables for these. Also, some people don't want to keep secrets in these YAMLs or in the environment variables. I've seen mentions of there are ways to have secrets kept elsewhere and have the collector go find those and bring in these secrets. So of course we need a username and password. We need to know where the Postgres server is. And so in my case, I was localhost 5432, the usual Postgres port number. And remember, we had to have the address of where we're sending it to. In this case, the Signos cloud. Again, you could run this. You can self-host and run it locally if you want to, but I was using the cloud version. And you need that ingestion key that I said I just copy pasted off their website. And for your copy paste convenience, I learned to make a little text file so I could just copy paste these out. And here is their suggested config file, Signos's. Whoops, what did I do? Yeah, so they actually did the configuration in two parts. They did one file just for metrics out of Postgres. They did another one for logs out of Postgres. And so it's neat because you can have multiple of these config YAML files and then feed them all together. So I actually ended up running with 3. I had the host metrics, and then I did, by the way, that was kind of nice just to start. I showed you that screenshot. Then I came back and I added the other 2 YAML files just for Postgres. So we're not going to read every part of it, but I've colored what I want to point out. There are comments, most of which I deleted. And here's where we're using those environment variables to tell it where to find our Postgres server. And here's the metrics that we want to collect. And over there is a processor. That one looked curious. I haven't looked into it, but it adds OS information to the telemetry coming out of the Postgres. And then here's the bottom part of this same file for the metrics in Postgres. So we had to tell it where to send it, which is we want to put it out to the Signos server and then make it go. And for the logs, we had needed one more environment variable, which is where to find the log file in Postgres. So in my case, I was using the Postgres.app, which is really neat on a Mac, by the way. You don't have to install Postgres. It's double-clickable app. But it meant that the log file was in a funky different directory place. Although this app tells you, it has a nice little button you click and it tells you where all of the items like the log file are kept. So it also needs the other values that we already defined, where we're sending it to and that ingestion key. And again, copy paste. So this file's a little longer. We're not going to look at all of it. Just notice that they're doing a regex because the Postgres log file was not built for OpenTelemetry. So this thing is just pulling out the value from the Postgres log file, chopping it up into pieces, and then providing it to our OpenTelemetry backend. And again, you can get a sense for what it's doing, different log levels that you want to include or not include in your extraction out of Postgres. And then we set up a batch file because, of course, there's lots of logs, so you want to batch them for efficiency. And we're going to send them off And then this is the make it go part again. So now we've set it up for Postgres extracting the metrics and Postgres logs. And making it run this is an example where I'm using all 3 different YAML files, config files. By the way, their documentation uses longer names. I kind of shorten the file names because they can be whatever you want, obviously, because this is where we are calling the contributor right here. I mean, the OTel contrib is our executable, and we're saying use these 3 YAML files to do your work. Does that make sense? Any questions? Yeah.
I assume there's some way to deal with like log rotation, right, where your file names get changed.
Oh, I do not know about that. Yeah. But that's all that is going to be in your YAML config files. Yeah. So you need to look up the documentation for all those sub pieces of the Postgres receiver to figure that out.
The metric format, like when you showed the metrics going up to standard out.
Yeah.
They look like
actually it's standard by the way. Yeah.
That's an important station.
It can be, yeah. I actually mentioned it in the slides too.
They look like Prometheus format. So like if you already have a bunch of Prometheus-based tooling, it's easy to kind of like adopt OpenTelemetry is what it looks like.
Oh yeah, and I'm sure a lot of it was Prometheus was a big inspiration for OpenTelemetry. So yeah, I'm not surprised. Yeah, it probably is very similar. So the last part to making this work, this was on everything we did right here is me setting up YAML files on my Mac with the that's hard to say, OTel collector on my Mac. That's running on my Mac. We're trying to send it off to the Signos cloud service. So when we do that, we need to add a integration on their website server. So they already have a nice pre-configuration one for Postgres. And when you hit that configure, there is a dialog where it will ask you, it's either will lead you through everything I just talked about, or you can just click and say, I've already done it. So that's how their website has a tutorial. So I had already done all the pieces. I could say, yeah, I've already got it set up. And my collector was already running. And now what we're doing is to tell Signos to expect that to come in and to create a dashboard by default. And so sure enough, there's my dashboard it created by default. It's just a tab on the side. Under integrations, one will be Postgres. So super easy to get started. Only then I didn't know, it was kind of boring because it was all flat lines. So what's the easiest thing I could think of just to get started, to try to exercise it is the very first one is inserts. So I went in there and did 4 inserts manually using PSQL. And sure enough, boom, my line moved. I was thrilled. So, and that because it's working, I'm doing the inserts. I flip over to my web browser and see that the line has moved. And yeah, zoom in just to show you. And now, of course, like the axis and the scales and the colors and all of this is all being controlled by Signos. So again, the whole point of OpenTelemetry is you don't have to use Signos if you don't like it. You could use Grafana and configure your own charts and your own dashboard however you want to. And you could use whatever storage backend you want to. That's the whole point of OpenTelemetry is that you're not locked into any one vendor. And in fact, I mentioned earlier that the SDKs, they provide SDKs for all of these languages. So if you're an app developer or writing a service, you can provide hooks into your product so that OpenTelemetry receivers can reach in and call your product, or your product can call OpenTelemetry. And these are all actually managed by the OpenTelemetry project itself. So they are all officially supported. They are also working on 3 more, Perl, Lua, and Julia. So like I said, it's very rapidly expanding. There's so much momentum now behind OpenTelemetry. And lastly, if you're going to do in production, you can actually create they have a little tool, a builder, and it will make your own distro basically. So because for security, you may want to minimize the size and also the surface area for hack attacks. So it makes sense that if you're not using particular receivers, processor, and exporters, there's no reason to have them deployed in your production site. So they have a little tool to basically create your own distro. And lastly, I can't believe I'm actually under time. This was 60 slides in 40 minutes. I found this really useful. There's a little 34-page book if you're brand new to this idea of observability across distributed systems. It's a commercial book by O'Reilly. I actually read it for my library. They had the online Safari O'Reilly, online book reading. So it's a little booklet, 34 pages. If you want a big fat book, there's another O'Reilly book that's written by this group. And if you notice over there on the right, it says honeycomb.io. They're yet another vendor for OpenTelemetry related products. They actually provide this book free go through their website. And I just barely glanced at it, but like 300 pages. And the OpenTelemetry website was super useful. Like I said, the AIs, it's kind of my first practical mission, using AIs, doing this learning curve of this product with AIs. And it really was surprising how I was asking like about particular terms and very focused questions, even these URLs. There's a ton of presentations on OpenTelemetry. I find most of them are a lot of hand waving and concepts, kind of the first part of what I did. But my purpose of this talk was to get a lot more practical. It's like you can, walk you through exactly what you need to do to actually start using OpenTelemetry. That's where a lot of the talks are lacking. But a couple of the better ones are these two from both on YouTube. And that's it. But we actually have a few minutes for questions.
Did you get a chance to mess around with the eBPF collector?
No, I'm not a Linux guy, so no. No.
You go back to your slide with the logos and supporting stuff.
Oh, the languages? Yeah, so C, C#, Java, the Ruby, Rust, and Swift. JavaScript, that's Erlang, Go, PHP, and Python. So all of these are SDKs so that if you're a developer, like if you're writing a backend in Java, some kind of a web service that's being written in Java, you can add their SDK to it. And then what's cool is that that's part of the enthusiasm I saw at the Linux Fest. The speakers were talking about, as a developer, they didn't have to care about. One group was using Datadog to do some, so that meant they would have to go get the Datadog SDK and install it in their Java app. And then, oh no, it turns out that some other group wanted to use Splunk or whatever. And so you have to use that SDK. And so what would happen is the developers would learn one SDK and then not want to have to learn another. So then they were tied into the Datadog. So the idea is you eliminate that whole problem. If you just use OpenTelemetry, these SDKs in your development, then you as the developer don't care if they're picking Splunk or Grafana or Datadog or whatever, or Signos, because none of that's going to change what you do as a developer. You're just putting these OpenTelemetry hooks in your app.
I guess in theory, the docs contain the information on, like, if you're using other stuff doesn't have a critical SDK, here's a jet, right? Like other docs.
Oh.
Because like you said there's eBPF and you wired just to get like Postgres stuff in there, right? So like there's these other things that aren't listed with these SDKs.
Well, aren't you going to be working in C in that case?
Maybe.
Yeah. So.
But I could maybe I'm doing like a. Well, I don't really.
Yeah, if you're actually hacking.
If you're doing PLSQL or something, PLSQL functions, maybe you want to wire that up. But.
Oh, I see. I hadn't thought about that.
I guess it's like sort of two different layers, right? Because I guess the collector can go and grab like the metrics out of Postgres.
Well, remember too, you could create your own receivers. So, and I was telling this guy, there's a brilliant guy in Seattle that runs our Seattle Postgres group. He several years ago basically did all this himself. He basically wrote all of this functionality himself. And he did just amazingly creative ways of monitor, because he has some huge Postgres systems in production. and he's the only guy running them for the Postgres side. There's a IT team, but he's the Postgres guy. So he wrote a whole bunch of tools to do all kinds of queries into all these different Postgres servers that are running. And really, you could look at his talks from a few years ago. Well, it occurred to me basically a lot of what he did, he could have written receivers. And then he was pulling out the data, creating databases, and then feeding it into Grafana. Well, OpenTelemetry food chains of existing products do all that work. So he could have instead just wrote receivers to make his queries into Postgres. And then those receivers could be calling those PLSQL functions too. Because remember, they're just doing, like they're hitting those SQL PG stats and all that. That's all they're doing is hitting the monitoring features that Postgres makes available. Which there was a woman who gave a talk first thing this morning, and she mentioned she's an old Oracle person, and she loves Postgres, but she did point out that a lot of the monitoring capabilities are a little lacking in Postgres compared to Oracle. She's used to very rich monitoring tools to see what in performance, in a production system in Oracle. And she said that is something being worked on in the Postgres community is they know they need more monitoring tools. So then that means that this receiver, or like I said, people can write other receivers, could be written to call on those monitoring features that are built into Postgres. Any other thoughts or questions?
Thanks for coming down.
All right. Yeah, it was fun. The great thing about doing a talk to learn something is you have a deadline. So I didn't point out one of those charts had a date on it of today, because right after midnight I was tooling around with it just to double check things, and snapped one of the pictures. It was, I would say, doing this, the Signos made it happen for me. There's no way I could have done it without their tutorials and their copy paste, the YAML config files. But I do want to emphasize that you're not, again, locked into Signos. There's only 2 lines of stuff I showed you that was specific to Signos. That's the cool thing, is that, like I said, as an administrator, just like the developer uses one of these, they don't have to learn all the Datadog kits versus Splunk kits. It's the same thing on the administrator side. They only have to learn the YAML scripting for OpenTelemetry, and then that will feed into whatever kind of backends and observability front ends that they want to use. So, like I said, walking through that Signos, 99.9% of everything you're learning and looking at those scripts are the exact same kind of scripts you'd write for another product.
Yeah, that's a pretty compelling, like on the developer side of things, if I instrument my code to expose certain metrics and stuff, especially like in like debug builds, right, where you want to add like extra trace points and extra counters and stuff that you can harvest like during benchmarking or build or whatever CI. The fact that that doesn't have to change, and you can pick different vendors for your downstream stuff, like, oh, we want to use Signos. That's great. Like, wait, I don't have to then go back in and rewrite all of that instrumentation to add. Which, like, a long time ago, there's this a monitoring stack that was like predecessor to all this, like graphite and carbon and cacti, like these really early monitoring systems, and they each had their own kind of like wire protocol presentation. Yeah.
And their own terminology.
Yeah,
Yes.
exactly.
Yes. So their own software kit, their own protocol, and their own terminology.
So
right.
if you switched from one to the other, you always had to rewrite all that instrumentation.
Yeah, I'm glad you used the word. I should have noted that the word. Part of what I was trying to do in this talk is to give you all the terms you need to work with the AI. So you get your prompt for the AI is right. You can learn a lot. So instrumenting is what we're talking about here, where I'm writing a Java backend and a web service, and I want to provide those hooks into OpenTelemetry. I'm using this software development kit. That process is called instrumentation. So, or instrumenting your app. And Yeah, I keyed into this as a developer, but it was funny because those talks I saw at Linux Fest, a lot of the enthusiasm for the admin side, and it's the same motivation, right? It's like you have all these different products and all you got to crawl through all their documentation, all that goes away. There's just one way of doing things with the OpenTelemetry, and no downside because there is so much buy-in from the industry, all the vendors, commercial and open source. That's what they were excited about. Is there's so much energy into them all agreeing to OpenTelemetry. By the way, not all of this is exactly done. Like the Postgres receiver, there are parts of it that are beta, I think they called it, parts that are stable. And even OpenTelemetry is itself still changing a little bit.
You don't have
Not radically. It's been, I mean, it's production worthy for at least a few years now.
you don't happen to know or experimented at all with like any of the existing Prometheus exporters, because a lot of vendors have written Prometheus exporters for their products and stuff. So there's a Postgres Prometheus exporter, there's like an Elasticsearch one, a MariaDB one, a MySQL
Right,
one.
right.
And again, like you mentioned, like the
It still plugs into this. Yeah, they're handling they're exactly. Yeah. Yeah. Some of the older protocols are supported in the OpenTelemetry collector. And that's what I was showing you. We actually saw that with the Signos. They were using the OTLP on this left-hand side, and then down below was the Prometheus protocol was being used. They named it Prometheus, which was a little confusing to me because what we were doing was naming our receiver, but it was using Prometheus protocol in order to get data out of the OS for OS monitoring. So yeah, same thing on the exporter side. Your exporters can send stuff out in some of the other older protocols, and that's all for backward compatibility because that way you could have a you could use an exporter that's sending out Prometheus to a backend that only knows Prometheus and doesn't know about OpenTelemetry yet. That's the idea is have a, I mean, all of it should transition eventually over to OpenTelemetry because like I said, there's no downsides that I've heard of. Everybody is, in terms of there's not like lacking features in OpenTelemetry, or if there are, they're being worked on. Like I said, it's still evolving, but it's most of the way done. And like I said, I didn't see anybody saying, oh, I can't give up my data dog to use OpenTelemetry because it's missing XYZ. I didn't see anything like that. That's the cool thing. They can keep their data dog on their storage and on their analysis and querying. And that's why the vendors buy into it because it's actually kind of doing them a favor. They don't have to write these SDKs anymore for developers and they don't have to support them. And they're making their money basically by selling, the administrators on the back end and front end of observability.
Yeah, because like almost like 5, 8 years ago, before this was like had any momentum, this is like a glint in someone's eye back then. The big monitor, the hegemons of the monitoring world were like New Relic and Datadog. It was like a race to build integrations
Yes.
for everything.
Yes. Yeah, there's big money too because of the explosion in the distributed systems now. The microservices and all these, like I said, the containerization now adds a whole nother layer on top of all the cloud services and the virtual machines. So when you put all that together, there's a whole lot of it's kind of fun. I saw somebody mention about how it's like a lot of that was sold how it was going to simplify life, simpler and simplify for developers and for administrators. What it did is create this whole new level of admin of managing all these distributed systems. And so,
One like error or one failure in production turns into like a 2-month-long murder mystery now.
Yes, and that's why they come up with the traces to try to get a handle on. One thing leading to another.
You can like capture the whole like saga of requests through this service-oriented architecture and containerization cloud native architecture layout.
Mm-hmm. And remember,
so we'll talk more later because I've got some questions about pushing versus pulling stuff like that.
Oh, okay. All right.
Just an FYI, so it did a quick Googling. There is actually a PG Hotel extension. So you can basically build an extension to provide SQL level functions that do OpenTelemetry based out.
Oh, so from that you could call out to your receiver.
BGSQL.
Oh, wow.
Functions, and then it will, I guess, it admits it out so that
Oh yeah, I could see that being super useful where the complicated ones where you want to know that they're being executed. And for example, how long did they take to run? How did that one SQL function take to execute that it itself could report to the receiver? That's pretty cool. Yeah.
So apparently there's some
That's
work
neat.
in that area.
Yes. All right. All right. Well, I guess I better get out of here. Thanks for your attention.
Yeah, thank you. That's great.